Okay, let's give you some practice. So the equation for this line, here is given by this. So this arc here corresponds to this one here. So when you revolve this 360 along the y-axis, you're going to trace this out. Okay, so work out the surface area of this, and you're given the coordinates here to be this. The coordinates here is this. So revolve this 360 along the y-axis, and then that will then give you this. Work out the surface area of this. Okay. So press pause and have a go. So to do this here, try to visualize this in your mind. You're summing up everything here. So you're moving along. Here. So try and visualize this in your mind. So you start here. So really, you're summing up everything from 5/8 to here, which is 1. Okay, and it's going to be something dy because you're moving along here. And the thickness associated with this slice here is dy. So it's going to be something dy. Okay, so let's just look at this one particular slice here. Once you've got your length here, remember you need to work in terms of the x direction. Luckily, we've been given a formula already in the x direction here. So this is the x direction here. Once you've got this, then rotate it and work out the circumference. Well, this here is your radius. So when you do this, try and visualize you doing this. This thing here is your radius. So now you need to 2 pi r it. So you need to 2 pi r it to get the circumference. Once you've got your circumference, so hang on. So the surface area is given by this 2 pi r the radius, and this is your radius. Okay, this is your radius. So we can put it into here. So 2 pi r. So this is our circumference. Now this here is our arc length. And remember, we are working we are working in terms of the x direction here. Okay, so this here is your circumference, and then this here is your arc length. And just bear in mind that you need to work in terms of x equals something. So we need to find the derivative of this. We need to find dx by dy. So that will then, so remember, you are working in terms of x equals something. So differentiate it, and then that will give you this. So once you've got this, we need to square it, and then we need to add 1. Okay. So let's concentrate on this bit here. So starting with your x equals this thing here. So that was what was given to us. X equals something. Okay. So we've got x equals something here. So starting with this, we need to work out this. So differentiate it with respect to y. That will then give you this. Okay. Tidy up. It will then give you this, and then square it. That will then give you this, because when you get this thing times by itself, then you just add these two together. That will then give you this. Okay, tidy up, and then well, translate this. This means this, and then square it. Squaring it will give you this, and then add 1. So this is adding 1, and then these two will cancel each other out, giving you this. Okay, so once you've got this, look back at our original formula for the surface area. This here is your circumference. This here is, in a way, your arc length. We've just worked out this bit here. So let's put this whole thing into here. Okay, so that will then so when you put this thing into here, it will give you this. It will give you root 2y over this thing here, and then it's really a matter of this root a over root b b, and then that will then take you to here. Okay, and then so this block here will cancel out with this one here. So these two will cancel out. Okay, so that will then give you this. Oh, don't forget 2 pi is a constant, and then take this constant out. Okay, so that will then give you root y. So now it's just a matter of integrating this. That will then give you this, and then now jump to your calculator. So it's really this thing here, and then you've got this, take away this. So that would give you this, and then jump to your calculator, and it should be approximately this. Okay.